So every Wi-Fi product comes into market has to go through a journey of rigorous testing to be in the market, and we all use it. So today we'll be discussing about the evolution of Wi-Fi over the years, Wi-Fi lab testing over the years, and we'll be highlighting the gap between what are lab promises and live challenges we see in the real environments. If you take an example of real home, if in early 2000s maybe, a home has maybe one desktop computer with a Wi-Fi connected to the using a modem, and maybe the basic use case was browsing Google or Yahoo.com and maybe sending or receiving email, and up to the max, typically downloading a file. So fast forward to now, we have a modern Wi-Fi ecosystem where we have different types of real devices, from smartphones, laptops, IoT devices, thermostats, air conditioners, refrigerators, and many more. And now it's not just about browsing. It's about how much bandwidth they use, and it's more about latency-sensitive applications like streaming, gaming, and upload traffics, whichever on cloud-based and all. And let's see how the Wi-Fi testing has evolved. So earlier the testing was like benchmarking and most related to the standardization of throughput numbers, performance, and which is very repeatable, scalable, and which can be very much automatable, but it lacks a realism. So as the Wi-Fi testing has moved closer to the reality, so we have now the rise of the test houses testing, where we test in a realistic environments with different variety of devices. Here we have the full realism applicable, but we lack automation, scalability, and repeatability in these kind of situations. So let's see what are the challenges we face in the realistic environments, and one after one. Yeah. So RF and interference. So interference actually spikes if you have a neighboring route, not networks handling, or you have BLE clients, or there is a door opening and closing. The test results always change when in a real environments. And next, mixed client of devices. If you have some clients placed in near, medium, and far, variety of devices, maybe normal real devices or IoT devices mixed. If a client is moving from here to there, the performance doesn't stay same. The roaming patterns doesn't stay same. So the mixed kind of devices, the OS updates might happen when you are triggering a meet test, or there can be a thermal throttling running over there. So that might be impacting the performance or test which you are running over there. So next is like the application behavior. So each application demands are different. The QoS demands are different. For example, for streaming, it's different QoS demands. For conference calls, if the demands are different. So based on demands, the behavior also differs. And it is very difficult to test in a real environment. And apart from this, the native application usage and the usage using a browser differs. And even the bitrate, which adaptive bitrates, we all see the adaptive bitrates now. The user experience is most important now. So next we have debugging issues. This is the main issue as we observe while doing testing in a test houses, where the time synchronization issues, DOT logs are different, test tools logs are different, sniffer logs are different, and even you are able to sniff the packets accurately. There are many chances that you are not able to sniff all the client packets there, and you miss the packets, and debugging is very difficult at that point of time. Next is like environmental variable. So recreating the home environment, again, like an office environment or the stadium environment is very difficult in these kind of scenarios. So, so there should be a place where we should balance the repeatability, scalability, automation, and bring the realism here. So we have to have the test setup which actively acts as realism as well. So here comes the real world Wi-Fi environments where where this is a test bed where we emulate the virtual clients, place real clients at various distances, near, medium, and far. Using attenuators, we add distances. I'll explain more about this. So what we have done is we have taken different device and traffic profiles. So it's adding just real devices to a test bed is not enough. So realism adds by the user experience. So we have taken few devices in our lab, profiled them. Like, I don't know if it is visible. Profiled them based on device type, mode, bandwidth they connected, NSS. So we profiled them and listed out a few devices. Like many devices here, we have listed a few devices. And we have also profiled the traffic profiles. So traffic profiles, like we have taken a Zoom test. We have run a Zoom test in ideal, like best experience, and like logged which protocol it is running, which traffic type it is running, and at what payload and what is upload and downlink rate, and all the details we have just logged it here, profiled them, and applying it to different devices. So here we have device profiles. Like we have device profiles like laptops, phones, like some have Samsung phones, some have OnePlus, some have laptops, Asus laptops, some have Lenovo laptops, HP. So they profile the devices, add connected to, and different traffic profiles, like different traffic profiles are running, some Zoom are running, on the some different traffics are running, placed at different physical distances, near, medium, and far distances, to make a scenario. Like we can make different scenarios here from office spaces, residential homes, hospitals, stadiums, cafes, restaurants, and each environments we can have different scenarios. Like scenario may be different from like small studio apartment. There is only 10 devices used, but in a villa home, maybe 50 or 60 devices might be used. Based on environments, this test bed can be achieve multiple best results over there. So let's. I'll hand over to Rudra to check on few use cases here.
Let's see the use cases across, let's see the use cases and see how we can balance the traditional lab testing and real user experience tests. First we'll go with the ideal lab conditions. By using this test bed, we have ran a test with a single client with total intended load of 10 Gbps, and we are able to achieve more than 6 Gbps of throughput here. And we have repeated the same test at different distances, near, medium, and far. And we are able to see consistently, like at every distance, the expected throughput we are able to achieve. Now, like by using the same test bed and same DUT, we created with a mix of device profiles, traffic profiles, and distance profiles. For example, you can able to see different clients across different distances with different traffic types like YouTube streamings. Few IoT devices are doing on and off operations. Few are doing WhatsApp calls. Few are doing like YouTube streamings, like so on. So like different traffic types, like we are streaming by using these different clients. And we created a scenario called single story home scenario. In this scenario, we have used mostly 20 to 25 clients with total intended load of 150 Mbps. And let's see the results across different traffic types and different device types. If you see performance across different traffic types, most of the traffic types here requires, consumes very low bandwidth and requires less than 5 Mbps of bandwidth. And even like we are able to see some of the failures while running this traffic types in certain devices. Even same few of the devices got failed while running some certain traffic types. We have ran same test by using the same test bed with same DUT with different realistic environment scenarios. One of the scenario we have ran is like studio apartment scenario. In this scenario, like we have used approximately 15 clients which are spread across different distances, and with total intended load of just like 95 Mbps, it is less than 100 Mbps. Even we are seeing failures on few devices which are running certain traffic types. And we tried with like college library scenario. In this scenario, mostly we'll use mobile phones, laptops, few surveillance cameras. We created a scenario with certain device profiles and traffic profiles. Even in this scenario, like we used approximately 30 clients with total intended load of 220 Mbps. Even in this scenario, like most of the device profiles required very less bandwidth. But while running this scenario, we are seeing failures in few of the devices while running certain traffics. Same like that, we tried with multiple realistic environment scenarios, and still like we are seeing some of the failures in few clients while running the traffic. Same as like we created a scenario called stadium scenario, where all like mostly in stadium people might use surveillance cameras and like mostly mobiles they will use. In this scenario, like with complete set of different variants of mobile devices, and we created this scenario, and in this scenario we have used approximately 50 clients with 430 Mbps of intended load. Even while running this scenario, we have seen some of the failures while running certain traffic types on certain devices. We have observed few other issues with this DUT by using the same test bed, where we can able to achieve more than 6 Gbps of throughput, but when we are trying to run a realistic environment scenarios, we are seeing the failures. Poojitha is going to explain about the next issues, what we have seen.
So far, you have seen multiple realistic scenarios like home, cafe, restaurant, stadiums, etc. So in this real environments, we have tested with multiple DUTs, in which we have encountered some stability issues with the DUTs which we tested. So let me walk you through some of the observations which we have. So this is the first issue which we observed. So we placed a Wi-Fi 7 DUT in a controlled environment across near, medium and far distances. At near, when the RSSI signal is pretty good at minus 25 dBm, we're able to achieve 9 Gbps of throughput. As we increase the distance of the client, we are able to achieve 1 Gbps of throughput, which is pretty consistent and expected. So now when we subjected this Wi-Fi 7 DUT in a realistic home scenario which we showed previously, so we have used 16 clients and we have induced different traffic types and device profiles into the scenario. And then we have run a basic throughput test. We're able to see a DUT crash throughout the test duration. So we have run a 1 hour test duration, the DUT crashed for 3 times. So the same DUT which has given a 9 Gbps throughput in an idealistic environment crashed when we have placed it in a realistic environment multiple times. So this is one of the observations which we have. And moving on to the second observation, now we have used the same home environment. What we have done is, whatever the traffic profiles which we listed previously in the presentations, we have subjected all those traffic profiles to one single QoS category. So here there is no QoS tagging, all are subjected to one access category. So most of, when we are doing any real application tests, most of the times we will be using only one access category while streaming or doing any other real application tests. So all the traffic profiles are now running with one access category, and we can see we have just run a basic throughput test, and throughout the test duration we are able to see multiple fluctuations in the throughput. And when we went and checked the packet captures, we are able to see multiple retransmission frames reaching up to 1000 packets per second. And also the clients which are involved in the test, those phi rates were also fluctuating throughout the test duration. And to add on, not only with the best effort QoS tagging parameter, we have also verified with the other QoS access categories like voice, video, best effort, and background. So when we are running all traffic profiles with single access category, the observation is same, and there are throughput fluctuations. Now what we have done is, as a further step, with the traffic profiles which we used, we have subjected the QoS categories as, if you are running a real application WhatsApp call, mostly we have subjected the QoS access category to be voice. So if you are running a YouTube streaming video, we have subjected the access category to be video. So based on the traffic which we are running, we have subjected the access categories and we have rerun the test, and in which we can see the throughput to be pretty consistent and stable, and in which the retransmissions were not exceeding more than 150 packets per second. And the file rates of each client is also stable. So now, so to conclude with the presentation, so the Wi-Fi has evolved a lot. So initially the Wi-Fi we used is only for the file downloads or to send mails to your friend, or maybe just like file downloads, or using for a very basic purposes. But now Wi-Fi became a commodity that we are using in our day-to-day life, not we're using for everything, like video streaming, WhatsApp calls, everything with real application tests. As the Wi-Fi has evolved, even the testing has evolved, not only checking for the idle throughput numbers, but also for the user experience level, where we are more concerned about the real application tests. Now, the device which is performing in an ideal environment might perform better, but when subjected the same device in a realistic environment may not give you the better results. Now, the network in a box setup, which we have shown in the previous slides, bridges the gap between the idealistic environment and also the real world scenarios, which we are testing in test houses conditions. So with this, I just want to conclude with our presentation. So if there are any questions, we're happy to take.
So throughout your presentation, what I see is performance numbers are captured, but I don't see anywhere is the client connected or not. So you are connecting almost 30 clients. So haven't you seen any client disconnections throughout the test?
Yes. Yeah, so while running this test, we are also observing the client connectivity status as well. So we are seeing like in with respect to real clients or with respect to few, like based on scenarios as well. Based on different scenarios, the client disconnectivity is seen. Yeah, we are seeing the client.
So that means test case is a failure, right?
Yeah, test case is a failure itself. Like starting, like what we are including in the test results, like based on device types and traffic types, it's the client which connected. We gave that data. We have add another data where the client doesn't connect at the initial stage itself.
Okay.
Yeah.
Okay. Thank you, everyone. Give it a round of applause for Rudra, Poojitha, and Veena.